All right, that's live on the air. Oh, cool. So sorry, I didn't take really much time to um, to right to do that, right?
Apology accepted.
New woohoo, and that creates this, and then I can do. I'm doing something in the background.
No.
Weirdly enough, so I can share something with you guys. So, anyways, I put two things on the agenda. So the one I just wanted to touch upon slightly and quickly, which is the I'm not sure how many people realize this, but so when I started the whole project, there was this class called Ehcaching that was being looked up using the service loader, and it was being looked up the cache manager builder, and that was the one thing that was used to create a cache manager.
This is akin to what happens in 107 with the caching stuff, right?
Right, but I deleted that, at least in my issue, whatever issue I'm working on thing.
Yep.
Because so that was an abstraction. I thought, it could enable us, say, like for clustered use cases, for the use cases and whatnot, to decouple things. But then we worked more on this on the caching front, and basically we ended up with this sort of implicit contract that now when you create Ehcache, basically the Ehcache class, right, that is the main cache class, implements all the known subtypes of cache. And that's an implicit contract, right? So the builder is actually totally open. So you could use the builder to narrow the type down to something more precise that only you know about. But that wouldn't work.
So you're saying you can always cast one to the other. It's that would
right. Each cache needs to be castable to
all of the things.
To all of the things. Since we're subtyping, it's an open set, or it's an infinite set of things. So anyway, so that's the contract for now. I got rid of, so basically there was this Ehcaching stuff that would do the magic for the cache manager, but I sort of applied it only. Yeah, go ahead.
I don't see if people want to do that. There's one you can do it in 107, and I don't see a huge amount of value in it.
Yeah, I think basically what we want to keep is Ehcache manager and Ehcache as being the foundation classes, right? These things are not pluggable.
Yep.
If
it is after all, it is a product and not a
right. And if we're wrong and it turns out to be useful that it's pluggable at some point, then, well, I guess we'll have to deal with that somewhere at that point. But so basically the contract is this now. Certainly on my branch, so a cache, what is it? A cache manager builder will actually instantiate a Ehcache manager directly, passing in all the stuff that you've configured on the builder. Actually, the service loader magic was actually missing. There was a test that proved that this code worked, but was only loading a test cache manager and not the real stuff. So now all this actually works. Well, again, on my branch, but it works exactly the same way as the cache does. Just wanted to make that known. I think it's probably fair enough. If it's not, we can go back to the other way if it really needs be. It's not like a huge change. But basically, there is this contract as soon as you try to specialize. And that's stuff that's in the API, right? So it's not like we're coming up with, so the things you can narrow to, like persistent cache, standalone cache, and all those things, are defined in the API module, right? So basically, your thing needs to implement all of that if it wants to be a good citizen. All right, so that's on that. And that leads neatly to the next topic. The next topic being this topic, lifecycle. Probably the most preferred subject amongst everyone here. All right. Present to everyone. All right. here we are. So for those who remember, that's what we said we would do.
Are you just showing this because Louis not here and you can blame him for it?
Yes.
Cool.
Yeah. I've been a backstabber all the way, so don't be absent. That's the trick. All right, so that's what we have, right? So the nothing is probably very easy. Nothing much to discuss there. So I'm actually implementing all this right now, and that raised a couple of questions. So as of now, the transition of new to available was implicit, so I'm changing all that.
From new, you mean from nothing?
Yeah, sorry, from nothing. When you call new, it directly went.
It goes directly to available without having to go through anything else. Okay.
If I move my mouse pointer over it, it shows. That's cool. So, right, if you call new, it actually went directly to
Straight
this.
to available.
There was no status really being exposed, but that's what actually happened underneath, right? So I actually changed that, and basically the very first question I have for all of you guys is, do we want to have a life cycle interface? Because this falls into a bunch of things. So, sorry?
What purpose would that interface serve? Do we think there are multiple things that share the same life cycle?
Certainly cache managers and caches. Certainly cache managers and standalone.
But is it the same life cycle? I don't know. I guess I don't know. My brain's kind of uncertain about what it means to say this is the life cycle of a cache, this is the life cycle of a cache manager. Oh look, they overlay one on top of the other. Let's make them use the same interface to drive their transitions. I'm trying to figure out what value there is in that. Are you ever likely to detach a cache manager from its identity as a cache manager and just use it as a lifecycle entity?
Oh, okay, yeah, that's
from an external user point of view.
From an external user point of view, there isn't. That was actually one of the questions. Where would we put this interface, right? And it needs to be, if you make it so that cache manager implements that, all of a sudden you need to go to.
It's plausible that we have internal uses for it, but I suspect not because cache manager and cache, but maybe if there are things like, if there are a bunch of anonymous services that the cache manager doesn't necessarily know the type of, but it knows that they're lifecycled and they share a common lifecycle interface, then maybe that's useful.
Right, because there are things, right? So right now, when a cache is uninitialized, then you call init on it, it's gonna go and try to delegate the init call to all the caches that you configured into it, right?
Right.
So create the caches, try to initialize these, and make them available, so that when your cache manager is available, all the caches it manages are also available.
Right.
Which might, by the way, for persistent one, include creating them and other things, right? Where am I getting with all this? So which in turn it also needs to delegate that to the store, right? Because we did say there is no graveyard. So if there is no graveyard, you can obviously always call shut down, reinit, shut down, reinit, shut down, reinit, shut down, reinit, and so forth. So there needs to be on the store, there needs to be an init, there needs to be a shutdown, there needs to be a create. Everything goes there. So we may be saying that they should be a lifecycle or lifecycleable whatnot interface, but that we only declare it as part of this sort of internal stuff, and we don't make cache manager nor caches extended.
Well, you can make cache manager and cache extended, but I don't know if the interface needs to form part of the public API. By the but the interface itself doesn't have to.
What?
I'm not sure that the cache interface needs to extend life-cycled thing.
Oh, that's what I meant right now.
Right. Yes. Okay.
Okay, so you're saying not to do that.
Yeah.
Okay, so basically you have public-facing types implicitly implement them when they need it,
Yep.
and have the internal stuff explicitly declare this as being a...
Right. One of the things. Okay. Say no. Do I mean this or not?
Because I realized that there are different cases, right? A cache manager, in the way that we did it so far, a cache manager wouldn't be cyclable entirely. A persistent one would, though. Or you could make it entirely life cyclable, but basically destroy on a simple thing doesn't.
Is a knob, does nothing. Yeah, there's some things that I'm looking at this and I don't quite understand right now, but I'm trying to remember if I understood them at any point or if I don't know.
Now's the time.
Bothers me that destroy doesn't. It bothers me that destroy from maintenance doesn't transition to a special state that says it's destroyed. From a state machine point of view, you kind of expect that if a state that the set of legal operations within a given state are stable. Did we? Why does it do that?
They're stable. So if you call it destroy, you can recall create on it, for instance. That's perfectly fine. You can call shutdown, you go to an initialize. The only thing you can't do anymore is calling init into it because it's going to fail. That's why we have the success in the init call. Right? So think of your cache being a persistent cache, right? And you got data on disk, right?
Yep.
You can't create it. The create will fail. So if you go to maintenance and there is already data on disk and you call create, it's going to fail. If you call destroy, it's going to delete all the data on disk.
Right. So this is the life cycle of a Java object that represents the cache manager, not life cycle of the cache manager. Has some kind of entity outside.
Right. This is why it says client side up there.
So right. Okay. So underneath this, there's this concept of this maps onto some life cycle of the actual sort of more.
Right, of the data, of the persistent data storage.
For want of a better way of putting it, the actual physical entity. Yes. Not that ever really is one of those things, but
yeah,
the pattern of ones and zeros.
Where basically I think what we had down there is nothing offline and online.
Okay.
So basically, so this is what this means, right? So if you got a persistent, so this way you can say that my cache manager that expects to persist data on disk, you either go maintenance, create, shut down init. That is basically creating the data on disk and making the thing available. And if you expect data to already be on disk, you just call init and you go straight to available because everything you configured, it will find the stuff where it expects to find it. But basically, there is not this. Basically, what we knew from the toolkit, which is get or create, right? The same being true for disk. And then what we said is what we could do in the XML stuff. Oh, we could even do this on the builder, by the way, right? We could have something that says get or create on the builder, right? So right now I changed the builder that when you call build, it actually calls init. So the thing you get back is always an available thing, or it fails, right? Okay. We could have another method on. Actually, no. I think what we said we would do is possibly pass an enum thing into it. So you could say start from scratch. So if there is no data on disk, cool, create it and start. If there is data on disk, scratch it, recreate it, and start. You know, all those things. That's the way we said we would do this. Which we don't necessarily need to do now, to be entirely honest, right? Because we don't need to push this to the full-blown thing because 107 doesn't require any of this. But we said we wanted to have the lifecycle in early in nonetheless, because pretty sure it's going to be impacting stuff.
Right. Okay. No, that makes sense.
All right. So I think that is what we have on the life cycle that we discussed.
What's the funky blue arrow that goes off the edge of the screen?
It's the other part of this diagram that I cut off in order to not confuse everything.
Is that a bad part of the diagram?
No, it's not necessarily that part of the diagram, but it forces us to talk about way much more scope than I'd like to see covered here.
Okay.
Okay.
Basically, yeah, it
I will
forces,
remain blissfully ignorant.
right. It forces us to talk about, yeah, the distributed world, which I don't want to cover here.
Fair enough.
So, so yeah. So basically, when you look at it, though, it makes for a whole lot of methods, right? So, oh, I was about to hang up. That's not what I wanted to do. Let me go to my IDE here, and let's say that I do Helm.
Don't like an enormous amount of methods, but
Oh, it's still non-neglectable, I find. So let's have a quick look at the crazy stuff that I did so far. Feel free to point out the nonsense as you see it. All right. So basically, we have an enum.
could you make that a little bigger?
Actually, I don't think I can, or I don't know how.
Oh, I was just thinking for the sake of people watching this on YouTube, but I can read it myself, just about.
It's all HD, I think. Is it not? It must be awesome.
Probably. Okay.
All right.
I'll just move my head closer.
So yeah, sorry, I don't know. It's exactly the same way as I screen shared the other times, though.
Yeah, I've explicitly not moved it to the bigger screen because I want to make sure that it was visible if somebody was watching on a small monitor. But that's
Okay.
cool.
So anyways, the point isn't really. So you get the init method, right? That makes a state transition from an initialized to available.
Yep.
You got the close that makes the transition from available to an initialized. Then you got this awesome create stuff to make sure that you're on maintenance. We also need to make sure that you're the one on maintenance. How are we going to do this
The exception's
exactly?
wrong.
What?
You copy pasted the exception from destroy and not changed the message.
Yeah, it's stuff that I was just doing like right
That's
now.
fine. Sorry, I was just yeah.
So you need to be in maintenance mode, right, to do any of these. But as I said, this would need to read like so, actually. And well, either I'm not sure which way is the best way. No, yeah, I think the way.
What is it going to be? Because I can't tell you until you show me what it's going to be.
Right. Well, I think what it would be is like container equals.
Right, then I would do that as.
Well,
You should be able to do that as status dot is maintainable or something, and it can check the thread. It seems wrong for that check to be. Well, I guess it's debatable, but you might want to consider internalizing that check inside another object. I don't know.
Oh yeah.
Or alternatively,
Yeah,
having the transition to having all the maintenance methods only available on an interface that is returned by the thing when it transitions.
Let's be honest, right? This is a maintenance thing. This is an enum. This could have a thread thing, and make sure that you can only set it.
Not if you've got multiple caches.
Okay, so
what I'm suggesting is that you could have it so that you could have a transition.
I'm being confused because, like, I'm being pinged in the back saying that it switches. I realized it should have switched at the beginning, but now I made it so that it's like I present to everyone. So I hope it's fixed and people are just lagging behind. Let me click myself, so now it's double sticky. So, anyways,
Is it still doing it? I have no idea.
I don't know because I see them like ramble about other stuff.
Anyway, I was just contemplating that if you want to enforce that contract, that when it's in maintenance mode, only the thread that's transitioned it into maintenance mode is allowed to do the maintenance. Surely the more sensible thing is to have the methods that are maintenance methods be exposed by the transition. So when you call move to maintenance, whatever that method's called, I forget.
It's right.
The return of that is not a Boolean indicating whether it succeeded or whatever. The return is the maintenance interface, and that's the interface that you do it through.
Oh, that's a good idea.
So the cache itself doesn't actually expose them.
And then we don't need to pollute the cache with all this.
Yeah, then that goes on the maintenance interface.
Yeah, I like that.
And then you can even make the maintenance object a closable object that automatically transitions it back out to maintenance if you wanted. And then you can do a nice try with resources kind of try resource thing, can't you?
It's maintainable.
Whatever. Maintain.
Maintain.
It's a horrible. That is not a serious suggestion for a method name. It's horrible. I don't know what you call it.
I would call it the maintenance. Right.
Yeah. Yeah.
Maintenance.
Right, and then we have that, and this call like basically.
And then create and destroy go on there, and there could be a whole bunch of things that go on there potentially.
Right, right, that's a good idea.
But they don't pollute the main cache interface.
That's good.
And they could, it could just return this as well, of course, if you wanted, but you probably don't want to. And then if you want to actually then do even more enforcement and make sure that it's the same thread that did the transition, then you can do that in the maintenance object.
Yep. That's a good idea. So that looks good, I think. That looks good. So other than that, okay, so that's cool. What there is, so Ehcache has historically been racy in many ways, but one way in which it's always been racy that I don't necessarily condemn is the state transitioning stuff.
Mm-hmm.
So if you look at this is obviously wrong. This init implementation is wrong.
All right.
There is this because it will say it's available here, but we've done none of this.
All right. Yes.
Right. So how do we want to go about all this?
Well, I know you talked about having the concept of non-exposed, of it having an internal state machine model and the public one, and having the effectively gets the current status would be a reference to an internal status object, and the get status would then be current status.get.map to public or something, so that you can have starting.
Right. But then let's say you got that, right? Now when you do the get status here,
all right, which would be current status.get.
All right, I'm gonna get to that. So
yep.
I'm just moving it up so that it's
okay.
Right. So this now returns like to public status. Okay.
Yep. Yep.
So in the case of a state transition, what does this do?
Well,
return the uninitialized, say, in this case?
Well,
or do we make this blocking until the state transition finishes?
I would have said it depends on what you want in it to happen. What you want to have happen in it. If you
Almost feels like there ought to be.
I don't think it should block.
I don't think
I
it
don't
should
think it
block,
should
but I
block
think
unless the method says it blocks. I think
there
it's a
should be
nasty
both.
thing.
I think there should be a racy one that never blocks and a blocking one that gives you some. If there's a blocking behavior that gives you some useful piece of information.
But to me, the blocking. Get
There is
status.
a useful. There is a
Like
useful.
I think there is, right?
There is a use for blocking, but to me, get status should tell you what the status is, and if the answer and every internal status should map to a valid public one, so it makes sense. Starting maps to uninitialized. It's not yet initialized. It's still uninitialized. It's trying to get out of it, but it's not there yet. To me, what you're really saying is, because the thing is, what would it mean if we say get status, then it's going to block, right? The answer is actually what you want to do is you want to say wait for status, and you're saying this thread wants to do something that is conditional on the status being X.
Well,
Right, but okay. So
I
think
don't know
about
about
user
that.
code here for a sec, right? Oh,
Yep.
oh, don't click here. Click here. Okay. Let's pretend. No, it doesn't need to be. Right. So
Use
let's
right
say I
nonsense.
got my cache manager.
Yep.
Manager. No. It's nonsense. How do you spell nonsense?
The way you
Word
spelled
that
it.
is never spelled. Nothing makes sense.
Nonsense.
If
It's nonsensical.
manager dot get status equals
Mm-hmm.
all right, the method's not there, but pretend it is, right?
All right.
Well, let me do this. Let me cheat a bit. What is it?
You see, I wouldn't do that. There would map that as if you call manager.init. Well, what's the intent there? Because you're assuming something about the API. What's the real intent? The intent is what you want to do is I want to use the manager.
Mm-hmm.
Right? But what you're saying is I know that the manager has to be initialized before I use it.
Mm-hmm.
So what you're to simplify, what it really says there is manager.initialize if necessary, manager.use. Right? You're saying
Yeah.
if I have to initialize it myself, I will do it. If it's already initialized, then let's just go straight ahead and use it. So why can't we just spell that out?
No, wait a sec. Okay.
Because you're assuming because
No,
you're
wait,
baking in knowledge about the status
I
predicate
realize I
on the
totally
initialize.
missed that. Wait, I totally missed it showing what I wanted to show. What? Why is it playing? Oh, because it's null. That's not what I meant. In a multi-threaded environment, right? If that's what I meant. If two threads come in here,
Yes.
I'm dead. One of the two is going to throw illegal state.
Right. But could potentially. If you're you have to
Given
be
what
lucky.
we have now, given the contract.
Yes, totally. But then the answer is that the method they want to call is not manager.init, but manager.init if necessary. And then
Okay,
it's
cool.
because
Cool. I can maybe believe that. I'm not sure I do, but that's fine.
because what you really want to say is
That's fine, Chris. It's fine.
Well,
That's
no,
it.
I mean,
What does the
that's
method look like then?
Sorry.
How does the implementation of the method look like? Is what I'm trying to get.
I don't want to define implementation. I want to define the contract. The contract is.
Yeah, but don't you then, if you have init if necessary, don't you then have to lock inside init if necessary?
Well, no, you basically. Yeah. So basically, what you're saying is, if there are two threads there, the behavior we want to see is that the first one in does the initialization, the second one waits for it.
No, what I mean to say is that if anything, this is what I mean to say. If this thing here, right? If this, so if get returns like
No, that's a way of achieving what I just said. That's not what you want. What I'm saying is, in your nonsense method,
right?
What do you want to achieve?
You have two threads that want to.
You said at the moment that if you two threads come in there, one of them will
for
throw.
real is that I wanna make sure that I never have to do that.
Do what?
Reentrant, read lock.
Whoa, no, that's not what you want to achieve.
Oh yeah, that's what I
that's
want to achieve.
a way of
You want the
avoiding.
user to be able to ensure it's initted.
Yeah, so what you want is to basically be able to say manager dot initialize if necessary, or manager dot initialize if necessary. If not, wait for other thread to have finished initializing.
Yeah.
You want to be able to have two threads call nonsense and have them both safely end up being able to use the manager without duplicating any effort, without illegally transitioning the cache, without either one of them throwing.
Yep.
So the question is, to me, the answer is if we think that's a sensible user use case, which I think it is, then what is that method called on manager? What is the contract? What should we? And init, if necessary, is a terrible name, but it's kind of getting in the right direction, I think.
Right, but it goes in all directions, right? The same is true for stop or shut down or close or whatever it's called.
Right.
It's so I have this problem like all over the place.
Mm-hmm.
Right, but then maybe the argument is the answer is that
because we said that maintenance you can only get it if you're the one.
Is that true? We can only have one maintenance object out at a time.
You can only have a single. Yeah, that's what we're saying. Yeah.
Person doing maintenance. But okay, so the answer. But the question is there ever a case where you don't want init to behave in that way, where you don't want it to say, I'm going to try and transition this thing into initialized. If it's completely impossible from the state I'm in, throw. If not, basically what you're saying, it seems that what you want to have happen is the way init should behave, whether it's init or some method with a name variation on that, is if this thing is already initialized, just return. If it's not initialized and I can legally initialize it, then boom, initialize. If it's not yet initialized, but it's in the process of being initialized by another thread, wait for the other thread.
If initialize.
When it leaves this call, you want to know it's initialized. That's basically what you're saying, Chris. When it returns, no matter which threads you were, you want to be able to depend on the fact that it has been initialized. Whether there were 100 threads or one, whether it was halfway done or not, like, if it returns without error, go ahead and say, yes, it's been initialized. Maybe not by me, but by somebody.
If initting, wait and return when initialized.
And there's similar holds for stop and.
And the question, and the question is, should we just call that method init? Do we ever want that? Do we ever not want that behavior?
I don't.
Man, I can see your point.
I feel uncomfortable with having this basically. No, yeah, I don't like the fact that then if you're initialized and you call init, it just says maybe it's fine. And
create a future. You could have them return. It's easy, really. What you want to do is a really easy behavior to trigger. I don't want to worry about how to implement it. It's not that bad. The thing is, I think that's really the behavior most people want.
I'd agree with you, Chris. That's what people are trying to do.
So you're saying that init never throws a legal state exception?
I didn't say that init never threw. I'm saying that the behavior that most people want is a method that does that. Yes. I'm not saying that there's not. I'm saying we need to figure out if there is a use case for a method that does throw to the public. Obviously, we may use it ourselves, but
I don't know. The pedant in me says that's what the contract should be. You call init. I think that's already an issue.
No, totally. I totally agree with you. The pedant in me says that's really like the fundamental raw base level thing. It feels like the users might want that, but I can't actually think why. When I'm trying to think of a concrete example.
I don't know that in a public API you ever want anything else. I mean, is there some utility in knowing not only was
to know that I fucked up? I don't know. To me, when I write my thing, my app would have a clear life cycle, right?
Can you fuck? I mean, would there be reason to code it so it's fucked up? Like
what kind of screw up would you get?
What would be the bad thing that would happen?
Oh, from a cache perspective, probably none.
I mean, you're saying, okay, if it's in the middle of starting, then we sit and wait till it's done starting, blah blah blah. Separate problem, but I'm trying to figure out what the user problem would be if it wasn't them that started it. Yes, there could be a programming error that
Here's,
three
here's,
people try to start it and we screw stuff up, like it's coded wrong. Yeah, but that's not users.
what happens if? Here's an interesting question. What happens if somebody calls this magic method that's kind of called init but kind of not, or might be called init, in the at the same time as another thread is trying to shut it down? Does it throw, or does it wait for the shutdown to complete and then reinitialize it?
Right. Do we give the behavior that the state transitions happen serially?
That's the one thing that's not covered there. What if it's in another? What if the state's different? What if it's
Well, if somebody's shutting it down, it'll end up back in it.
down?
Right. Well, it'll end up waiting, right? Because it can't. It's
Well,
waiting
no,
for it to be
me, it's still
uninitialized.
this. It's basically you're trying to compare and set casting to the wrong thing. So it basically you're triggering legal like transition exception.
Whoa! But what does the user what's the sensible thing from a user point of view to do in that situation?
Okay.
If it's in the process of shutting down,
If it's in the process of shutting down and you ask for it to be created,
initiated,
I would argue you'd want to wait when it's done shutting down, then you initialize it again. That from the user standpoint, those are monolithic atomic operations, and it doesn't. User doesn't care that it.
I'm kind of inclined to think that it should throw in that situation.
Then you just have to write a bunch of code that essentially is going to end up saying
No, I think I'm
do the
with
same
Fred.
thing. I don't think.
I don't much mind what the answer is. I'm just trying to figure out what the answer is.
Well, think about it. It sort of makes sense because
sounds weird.
otherwise you're sort of showing the raciness and you're actually exposing the internal state.
No, you're basically saying after every state transition, only one call can affect a state can request a state transition at a time.
Yeah.
And after each state transition, the next guy gets a clock.
Does that? What we're saying is only one kind of state transition can be requested at a time. We're totally happy for multiple people to request the same kind of state transition at the same time.
I don't see why that's from a user standpoint has any difference.
I'm not saying it is. So because one of the things I'm wondering is, does this encourage the pattern that before that people start writing code like nonsense, that they wrap the cache in a put call that where replace nonsense with put and the key value, and they just the bad example because this is the cache manager, but suppose we do the same thing for cache, which we think we're talking about doing, and then are we encouraging the use pattern cache dot make sure it's ready, cache dot put every time, with the assumption that if it is ready, then that's going to be a really low-cost operation. And then how do you? What happens if you're? That's when I'm starting to wonder what happens if you're shut down. Because if you then have a thread that tries to shut the application, if the application is trying to shut down, and you suddenly got all these threads that are still trying to interact with it, keep trying to tell it to start up again because they keep wanting the thing that they want to use the cache.
Right. Then I guess what you're arguing for is the exception. Then in this case.
Well, I'm saying that if that's a sensible use case, then the exception seems kind of like what you want.
Basically, when somebody hit, I guess you expect the thing to be uninitialized and once it's started. When somebody calls close, you expect the thing to be available and wants it to go to uninitialized. Now the problem is, what if it's currently transitioning?
Well, basically, what we're basically talking about is who is responsible for thread coordination during lifecycle transitions. Should it be us or should it be them? Throwing exceptions explicitly forces the users to do the coordination.
Isn't really the word because that's not what I want. That's not what I want to do. So this is why my take on all this should be that if you call, actually, I think I want what we have here, which is basically the problem is then when I call get status, that's the problem. So if this is the problem I see, if this is now actually returning, it's currently starting, okay? I call get status, and this actually returns the state to which we're transitioning, so it returns started. But we're not done starting. You know what we could do? We could have the other ops. We will have to check for the state anyways, right? In all our things. Why don't we make it so that if somebody tries to do something that requires the thing to be started and it's
you wait.
Right. So basically, we have a thing that says, say here, let's say add cache. I'm going to use this method, right? Check started, right? Check started will block if
starting. Until it started. That makes
Until
sense.
it started.
It does make
And then
sense.
it's all good, and right, all the other stuff works. If you call init and it's already initialized, it throws. If you call stop and it's already, it throws. And we can even lie here in the get status. It means it's gonna get there.
Yeah.
Arguably.
Of course, the other argument you can make is that the problems you're seeing are entirely due to the fact that you're trying to hide states.
No, there are not states.
Well, no, because starting is a distinct state because we're saying it behaves specially during it doesn't behave quite the same as it does in either of the other two states.
Yes and no. The thing is, I know how to fix all this so that we don't need state transitions. It's pretty easy, but it's gonna make the performance suck. So I don't want to do it.
Okay.
I can make it so that start is atomic and it locks the intrinsic.
No. I'm not saying you have to do that. It's fine.
No, obviously nobody's saying I should do that.
No, it's fine. I'm just saying
it's this thing where basically we're trying to pretend, yes, that it's an atomic thing, but we know it's not because if we need to make it atomic, it's going to be really costly.
And you're saying, but no, and what I'm saying is that you've worked around the problem for the moment, and we think we can work around the problem by saying that for as far as the user is concerned, starting maps to unavailable, but as far as internal operations are concerned, if you're the starting maps to available, but just not quite yet,
right?
I.e., it blocks until it is available. But what I'm saying is that we've wrapped around that problem, but I'm just not worried, but I'm saying there's a possibility we come up with a problem later that we can't reason our way out of, and we might be forced to expose states. But it's fine, and we can cross that bridge when we come to it.
Actually, I think the reason I kind of like the internal state, like starting or whatnot, is I think more for internal.
Yes, if we can hide it, I think that's great.
I think I think maybe some SPIs will care.
Yes.
About knowing.
You can expose it through the SPI, if you wish, and not through the API.
Right. I just believe that the end user doesn't care. That it's starting. It's starting. Okay, cool. And it blocks if it's starting. If we don't get to starting and we fail,
the point being,
that's one thing that might.
The point being that to the user, that it appears to be an instantaneous transition.
Right. There is one thing there is one thing that's confusing though in the model that we're talking about. If we let get status expose the targeted state, we just say start available, okay? And along starting up, we're failing, so we need to go back to uninitialize, right? So this, like, you can't perform any operations,
right?
So actually, I think this isn't correct. Nobody ever called stop, but somebody will be able to observe through get status, uninitialized, crap, what's the other? Available, and then back to uninitialized. I think this is wrong. If we make it so that this thing returns the targeted state and doesn't block.
No, it doesn't return the targeted state. That's not what it does.
Return?
So So here's my impression of what's happening. If it's not yet initialized, it returns. No, that's different. Hang on.
No, I think this needs to be blocking. That's what needs to happen. I think I think I'm going back to my initial thought. Get status if we're transitioning.
Something somewhere needs to, in order to keep up the illusion that init is instantaneous. Something somewhere needs to block. Either get status needs to block, or init needs to block, or the putty things needs to block.
Init obviously blocks, but this blocks, right? Thread A calls init, thread B calls get status. Get status returns when init finished. And returns what the state is.
Okay.
So any state transition is blocking. And then here it all makes sense too, by the way. We just need to make it so that this is cheap when it's not a state transition. And when it's a state transition, you pay the overhead of blocking. Does that make sense? Or did I manage to just confuse everyone?
It makes sense. It makes sense as a logical contract. I'm not amazingly convinced that it's the right thing to be blocking, but I think it's good enough for us to get on with. Does that make sense?
Okay, so let's start with that. And so when we discuss this,
and we'll see. I mean, I think that's good enough that we should push that with the 107 alpha, and then see what people say. And if nobody says anything, then we assume it's perfect.
Perfect.
And blame them all when they didn't reply, when they complain in the subsequent.
Well, the problem is if they only use it to the 107 API, it will probably be transparent.
Yeah, but they can't just use the 107 API because they can't create a cache very easily.
All right, we'll see. Okay, cool. So let me clean.
Well, I mean, the feedback doesn't have to come in one after. We basically, I think it's good enough to be going on with, and all we can do is wait for more feedback. And if we don't ever get any, then well, sucks to be a user if we made the wrong decision.
Yep. Cool.
Aren't we good at timing?
So what happens, I realize, I think this should fail right off, right? This should remain like this. This shouldn't wait for this transition to finish. If I go init, I'm still initializing. Another thread calls init. Now, if the first one fails to init, second one, if it waits...
What I would make that... what I would make that do... Oh, you might not like this. I would do... I want that to retrieve the current status and then transition to current status dot. So here's the thing, right?
Dot next.
Yeah, it should be. What it should do is it should do current status dot get, and then current status dot compare and set that to that dot init, and then it gets to then the state can choose to throw a special exception saying, well, I'm like foobar state and you can't transition to.
Okay, that way.
And then you can throw an exception if you fail to CAS because you raced and somebody else changed the state underneath you. They're different exceptions. The illegal state here is actually wrong. You can't initialize because it's currently that. You couldn't initialize because you lost a race.
Right, because this call is racy here, anyways.
Yeah, it's a bizarre thing to say.
Right. The state. So this is actually the current one. So that's current status.get, and that is
state.init.
State.init. Yeah.
And then you can, okay. So now the question is.
That returns obviously their thing.
Another state. Here's an interesting question. Should you be calling, or obviously you don't want to call get status because they're potentially different statuses, a public and a private, but should the current status.get at line 117 block if it's transitioning?
At line what, sorry?
117. Should that be a blocking variant so that if it is initially in the process of initializing, it waits for it to finish and then...
No, I would throw same thing again here. So I don't know what we do in this case, but we can do what we're saying.
Racing failure, blah. Don't know. Okay, it's fine. No, I was just asking. It was just an absent-minded question. But it's fine to say that it is. But you need to change the legal state exceptions message, but that's fine.
Yeah, but I'm not sure to what all it
race.
This is right. Yeah, I don't like.
Well, okay, there is a strong argument that says you should actually do that in a loop. If you lose the race,
this smells like you're making it really hard on the user.
No, No, that should be there should be a while loop there. Because eventually you should eventually either hit a state that is illegal.
Oh
to
yeah,
transition,
you're right.
Or because uninitialized should be illegal to init out of. It should be legal to init out of.
Right.
Starting shouldn't be. Initialized shouldn't be.
Yeah.
So that should be a while loop.
This should be a while. I think it might be better as a 4, but I'll figure it out.
It's just generally that while it's transitioning, you have to wait, and then once it's
No,
transitioned,
it has nothing to
It
do
doesn't have to wait. But the point
has to
is,
do with the race.
but that's what you're doing.
you should just because you lost the race, right? No, it won't. It won't wait while it's transitioning. The transitioning's dot in it will throw.
Right. The only way that you get this thing actually possibly succeed twice is because your thread gets swapped out, and for some
the whole
reason
thing blew up.
the other thing was initializing,
That-
right? So that one thread installed initializing here, but by the time you recompare and
come back,
set,
It's all fucked up.
the initializing failed, and so that it initializes twice in a row. That's what it may result in. Well, n times in a row with as many n's as threads are racing. But yeah, this is why I think a 4 is kind of nicer, maybe. An empty for loop always confuses the crap out of everyone.
That's definitely good. Yeah, if you can use an empty for loop,
I think
And
that's what
maybe
it'll be.
maybe a break and a continue in there, Alex, always helps.
Well,
enhance a
that's
for
right,
loop,
right?
right?
So what we want is 4 status s equals current. Oh no, that's not. Oh yeah, read that. Then current set states. Oh no, s. I called it this time. S. Net. And this. Then you reread.
Why would you do it with a for loop?
I just like confusing people.
Why wouldn't you just do it with a while loop?
I
Yeah.
like confusing people.
We just said this because unbounded ors are always better.
So while this is true, so it needs to be that. Sorry, now it's correct.
You're missing a space as well.
Space? Oh yeah. Oh, my
You're
God.
never missing a space.
There you go.
You're overspaced.
It's ugly because of the 4 underneath it.
Is this correct? I think it's correct, right? You get the state.
Yeah, but it's not very
return
compact.
the init.
Now, what you
I mean,
should
even
do,
computers IntelliJ, it's good.
you should do. What you should do is do the. Oh, you can. Can you do? Actually, maybe you can't do it any more compact than that.
If you run find bugs on it, it'll bitch about the empty for loop.
Oh crap! I'll have to back out then.
It really bothers me
I think that's correct.
the do while loops. The local variables inside the block are not in scope in the conditional at the end. That really bothers me.
It really bugs me. Yeah, I always thought that was a big miss.
Because it means you can't do this in a do while if you want to.
can't. Right.
No, yeah, I think that's the most.
It probably is the most compact way of doing it.
Yeah, it's just confusing.
That's why you have to end up doing
That's why both Chris and I want to do the do while, but you can't because if you
have to do
this,
you have to do
then-
the while. You have to do the while with the initialization outside and do it again on the pass inside, and it looks all klutzy. So this
which
looks
is the
better.
same as this for loop.
Yeah, but it looks better because this goes on a line. So screw
But
fine.
anyway, the good news is this has an empty block. Empty blocks always win.
With a comment that says no. You do a date inside. You do a
block
comment
to
that
left
says
essentially
no.
blank.
Left is an exercise to the reader.
So, no, wait a sec. No, yeah, it's correct, right? It's not. Oh my God.
Yes.
Keep going.
If it fails, you want to keep looping.
Yes, you're right.
Right, if it fails, we keep on looping.
Loopity doopity.
You realise that people are watching you reason about this in public, Alex.
What?
That's right.
Yeah, I did. That's fine.
Cool. I think that's right then. Now you
But
just
we
have
should-
to write that status enum.
Mhm.
And
Yeah.
the two of them, the public one and the private one. or internal, I don't know what to call it.
What should the default? What should I can override, right? Yes, I can. So what should it be? The default of all this method should throw, it should or should return the
Default
thing.
of all those methods should throw.
Should throw. Okay.
Yes, that's what I
Yeah,
always
that's
stuck with.
code.
Is
Yeah.
that they should always throw, and then you override them where they're legal. Prevents
Yep.
you from accidentally screwing up.
Awesome. There we go. That's going to be confusing.
If you switch to another file, no one can see it.
Sorry?
Did you switch to another file or something? Because the screen is
No,
not
I
playing.
didn't.
Okay.
Let me stop sharing. Okay, so that is it, I guess.
Bang
So
on 3 o'clock.
Awesome.
Was there anything else to...
The one thing that I don't like, though, is the two public status. No, wait a sec. What is it? Yeah. No.
I thought it
Oh,
was something-
yeah.
well,
Two public status now
I
needs
always
to
said as
contain
public
something.
status, but...
Right.
Why didn't you like that?
Wait a sec. What is
It's
it?
the method on enum. You can map them nicely.
Yeah, but it's the blocking one. It's the one that's going to be blocking in case it's a state transition.
Shoot, how do you implement that? Not easily.
Wait and return.
I would. Maybe you're gonna have to. Oh shoot!
I can't do that there, by the way. That doesn't work because I don't know what the outcome is. The enum never knows what the outcome is. It can't be that.
No,
It needs to
it'll have to be blocked. The blocking will have to be done
Right.
inside the cache manager itself.
Right, it needs to go like this. Right. If transitioning or something.
No one can see what you're typing, but it's
Oh
fine.
yeah, sorry.
We don't want to
No, it's fine.
make it work.
Make it work.
All right. So I do create two enums though, right? So status, and then I'm going to create the internal,
Yes.
like in the core
And,
stuff.
you're gonna have to do the as public status in some clever way.
Yeah. Oh, clever. No, that
Clever.
wouldn't look like me.
Not
but-
trivial way.
Yeah, because I still want. I want to find a way to make it so that it's cheap when it's not transitioning. Probably Alt-R8, I guess. Anyways, we'll see. It's
I
not.
would just make the. What I would do is continue calling out as public status and just make the ones that have direct mappings return a thing and the other ones throw. And then you can catch the exception and do the wait. Fast path is uber fast. Slow path, don't care
Not
about.
so much.
Yeah. Well, no, I can make the exception throwing not too expensive.
Well, it doesn't matter. It's a race. I mean, it's gonna. The thread's about to go block.
Right. Right. All right. Cool. Awesome.
Okay.
Oh, but yeah.
Clifford asked a question, but
Right.
I think we
We smacked him.
buried it into the ground. So,
General awfulness.
I don't think I think we covered that in so much detail that it's
And then
not.
blocking. Oh yeah, I think we covered that now, right?
Yes. I think it was a while ago he asked it, obviously.
Right.
So
All right.
everyone else
Cool.
is paying
Well,
attention.
let me go and implement this then.
Okay, and then we'll tell you how it's broken later.
Yeah, it'll be fun.
Cool.
All right.
All right.
Thanks.
Later, gentlemen.
All right.
Bye.